Hello, welcome back to the channel. Today we're diving deep into Kotlin Symbol Processing, also known as KSP. This is part one of a two-part series where we'll explore KSP, its benefits, and how to use it to build a powerful annotation processor. If you're ready to supercharge your Kotlin development skills, stick around. Kotlin Symbol Processing is a powerful tool that allows you to write lightweight, efficient, easy-to-use annotation processors. These processors can be used to generate code, validate annotations, and much more during the compile time. This video will start by setting up our project and writing a simple annotation processor that will allow us to generate some code. Let's get started. I have a simple JVM project running on Kotlin version 2.0. It doesn't have many things set up with it. It's a plain Kotlin JVM project. Once you have your Kotlin project set up, give it a name of your choice and ensure you have the latest Kotlin plugin installed. In my case, I'm using 2.0. The next thing, let's add the necessary dependencies for KSP. To do this, let's open our build.gradle Kotlin file and add the following dependencies. Firstly, let us add the KSP plugin. KSP versions are usually tied to the Kotlin version. Let's start by adding the Kotlin version. This is 2.0.0 dash the KSP version. KSP version that we'll use for this video is 1.0.21. That's about it. Let's start by building this file. Once the build is done, let us create our annotation processor. This will go hand in hand with our actual annotation. I like putting all of this in a separate sub-module within my project because it helps keep the project cleaner. However, you can still do the same in your root project. But for this case, we'll do it in a separate project on its own. This project will be a sub-project of our primary project. Well, that's project and a handful. But anyway, let's create a new sub-project that we're going to call processor. I will use a Kotlin module for this since I'm on IntelliJ IDEA. However, you could always create this yourself independently if you wish to. Make sure to select the Kotlin module. Give it a name of processor. I do not want the sample code to be added. I need to make sure the build system is Gradle. I'm currently using Java 17. As long as you're in Java 8 and above, you should be fine. I also do not want any sample code. For the other properties, I will leave them as they are. Let us create this project. Using the IntelliJ's IDEA wizard, you are able to get your project added successfully. It has its own build.gradle file. It has also been registered in settings.gradle.kts. There we have it. The first thing we'll need to do in our processor's build.gradle file, we will need to set up KSP to work with this sub-project. The first thing we'll do is to add the KSP plugin. com.google.devtools.ksp. The second thing we need to do is to add the actual KSP library into the dependencies. You'll notice within our plugin, we do not have the version declared. This is because the root project already declares the version, so we don't need to in our sub-project. Let us add the dependency for KSP in our dependencies block. Here, you will need to specify the version as always. Our library is defined as follows. We need to implement com.google.devtools.ksp. The artifact itself is called Symbol Processing API, and the version is tied to the Kotlin version, similar to how it was in our root project file. Let us synchronize this file because we have made some changes to Gradle. Next thing, inside our sub-project, let us create our annotation. This annotation is what we will use to understand how KSP works at different levels. Let's give the annotation a very simple name, my annotation. Since annotations are usually classes, my annotation will definitely be a class. But to specify that it is an annotation class, we'll need to add the annotation prefix. Next, most annotation classes usually do not have a body. Therefore, we can comfortably eliminate the curly braces. The other thing that we want to do is we need to provide the target upon which our annotation can be declared on. As we know from a previous video, annotations can be done on functions, they can be done on classes, and even variables. Let us make sure that this annotation is only tagged on classes. We have our annotation class targeting only other classes. Next thing we can do is we can declare how this class will be retained. I would like for my classes all to be retained at runtime. Brilliant. Lastly, let us add a parameter within our annotation that we can use to process for further information when this annotation is called. I will call mine value and it will accept the type of string. Next, let's create our annotation processor. This processor will be used to find the annotation and then perform any extra things that we want to do thereafter. Let's start by setting up our annotation processor. Create a new file, make it a class, and call this my annotation processor. With this in place, let us inherit the symbol processor interface. This symbol processor interface requires one method to be overridden. This method is known as process. Something else that we might want with our annotation processor is our annotation processing environment. This can be provided as a parameter to the classes constructor. Finally, let's add two more things before we start implementing our process method. The first one is our logger, and the second one will be our code generator. We want to use this processor to generate some sample Kotlin code. Both are available from the environment entity. You can retrieve them by simply calling the appropriate method. I like putting them in separate variables because they are easier to call. I don't like always calling the variable environment every single time. Because I have no intention in creating an actual list of annotated Kotlin symbols, I will simply return an empty list in the process method. Now I can implement all the other logic that I would like at this point. Firstly, let's get all the symbols that have our annotation. This will allow us to be able to identify whether a class or a function or a variable has been provided with our specified symbol or annotation in this case. To do that, we'll use the get symbols with annotation method from the resolver and then pass in the qualified name of our annotation class. You can directly use the string myAnnotation in the annotation name as part of the parameters that you're giving within get symbols with annotation. However, sometimes to be a bit more precise and to be sure that your annotation is exactly the one that has been given, we can use Kotlin reflection to do that. This will change into my annotation, get the referenced class, and call the qualified name within the referenced class. Next thing we want to do is we want to make sure that we are only retrieving the classes that have been annotated with our annotation. Our annotation, of course, can go with either methods, classes, or variables, but we want to be sure we are only retrieving the classes for this specific processor. This processor is not interested in dealing with any annotations that have been tagged onto things that are not classes. We can go through only the symbols that are classes by using the filter is instance Kotlin method. This will only provide us with Kotlin symbol classes, or rather, Kotlin symbols that have been declared as classes. This gives us back a list, and we can loop through, for example, use the Kotlin method for each, and then within here, we can do whatever it is that we want. First thing I want to do is to get the actual class that has been annotated with our annotation. We can simply use the simple name property from the Kotlin class declaration, and we can pass that as a string. Next, we might be interested in providing also a package. Similarly, the package name can be provided from the Kotlin class declaration using the package name property. The next thing, we can use the symbol processor environment to create a new file using the code generator property. Our file can be written as follows. This will be equals to code generator.create new file. Create new file has 4 properties. One is dependencies. The second one is a package name. Third one is the name of the file that you want to provide. And then lastly, it is the extension of the file that you want to output. By default, the extension is in Kotlin. If you want to use your symbol processor to do other types of files, you may need to override this property. For our case, we won't do that because the extension is already in Kotlin format, which is what we're interested in. So firstly, we can have our dependencies having the aggregating parameter as false. Now, this parameter asks us whether we want the output should be invalidated by a new source file or a change in any of the existing files whenever there is new information. So for our case, let's not have it aggregated. We don't really need that for now. We'll look into that a bit later. The next thing with create new file that we want to do is to provide the package name. We already have the package name. And last but not least, we need the file name. Now here, I would like for us to be able to differentiate our 2 files. The actual one that has the annotation applied to it and the generated one. So let us use something like get the class name and then annotate it with, or rather provide a suffix known as generated. The last thing that we want to do within this class is to actually put the code that we want to be generated inside this file. So let's use a buffered writer to be able to write to this file. So we'll have file dot buffered writer, and then let's use this buffered writer, and then we can do a few things here. Let me provide the parameter name in the lambda as writer. I had pre-written some of this just so as to save time. However, I'll go line by line. Line 26, I declare the package in which the file will be in. Line 27, you can provide the name of the class. Since I already added generated at the top here, I can just remove this and have this as class name. Line 28, I provide the function that I want inside this class. So in my case, I just have something that says print name, and this will just print the text that indicates this is a generated class for a specific class name. So this is the file that I've written out. It has a package with a specified package name. It has a class with a specified class name, and it has a function inside the class that does allow us to just print the specified message. This is a generated class for this class name. Finally, close out the class and end with a new line. The last thing I can do, I can just add some information for our logger. So we could indicate logger.info, and our message can be generated file for our specified class. Fantastic. So this is our annotation processor that simply fetches all the symbols with our annotated class. Nextly, confirms that all the classes that have that specified declaration will undergo the following process. So we'll get the class name, package name, after which we'll generate a new file within that specific package and with that given file. And then we'll use a buffered writer to be able to write through all the other things that we want inside the class. The other thing that we want to do is to set up our annotation processor provider. As we learned from our previous video, this is very important in order for KSP to be able to understand that there is a processor provided in a specific location. To do this, we will simply inherit the symbol processor provider within our processor provider. You are required to override a member within annotation processor provider known as create. Create usually provides the processor environment and returns a symbol processor. We will return my annotation processor with the given environment. In order for KSP to know that we do have a processor provider, we will need to set up one final thing. If we get into our processors project, inside the resources subfolder in the main source set, create a new folder. Call this meta-inf. This will require another subfolder known as services. Inside this folder, add a new file. This file should have the following name: com.google.devtools.ksp.processing.symbolprocessor-provider. After that, simply provide the name of the class that your processor provider has. The name of my processor provider is my annotation processor provider. Add this here so that KSP will be able to know that your processor provider is named as follows. This concludes how we write out our processor and our annotation. Now, the next thing we're going to do is we're actually going to use this annotation processor. The first thing that we're going to do is we'll head over into our build.create a file. The first thing we need to do is to have an implementation of our project, since we have our processor in a separate sub-project. And for KSP to be able to handle our annotation processor, we also need to declare our KSP implementation of the project. With that, run your build. Once that is complete, let's head over to our main.kt file. Within here, let's create two packages. We'll use these two packages as a means of just confirming that our packages were identified correctly and we're able to generate source files correctly as well. The first package, I will call it test1. And the second package will be known as test2. Inside test1, let's add a Kotlin file. Call this Kotlin file name class. And then call the other Kotlin file email class. So we have two classes, one in test1, the other one in test number 2. Let's start with test1. We do not really need the class body for this example, so we'll remove that. We will add my annotation as the annotation for the name class, and we'll provide the value as name class. Secondly, let's go to the email class. Similarly, we don't need the body, so we can just have at my annotation and then value can be equals to email class. Fantastic. Now, for us to be able to know whether our classes and our files have been generated correctly, we will need the application to build. Therefore, let us go into main. Let's have a name. Let's call name class. And email. Let's have email class. Now, as you can see right now, name doesn't have any properties that we can use. Alternatively, we also don't have the name class generated class. You can see the IDE is refusing to autocomplete for us. This is because for our classes to actually be generated, we will need for those classes to be built, and this can only happen under a build. Let us just add a small message. So we've generated name and email objects. We can run our function. Let's get that to happen. So it might take a minute, so let's be patient. So that works. Now, before we use our generated classes, it is important for us to know whether they were actually generated. Therefore, we can go into our processor subproject, into the build, get inside classes. You will see your annotation is there. You will see your annotation processor and the provider, which is okay. If you go under Kotlin, there will be some few things also created there. If we look into build, you will see com.rotobishi.test number 1. Now, test1 will have name class and name class generated. If you open name class generated, you can see this is some Java bytecode that shows name class generated that has a constructor, and there is a function that returns unit, and within here we do have some compiled code, which is okay. All right, that's okay. So our files have been generated successfully. Let's go into source main Kotlin, and now let's just say wow generated name equals to name class generated. So you can see name class generated is now provided by the IDE. Call that constructor, and you can also have the gen email. We have the email class generated, and then we can just do gen name dot print name, which is the function we created, similar case to email. So you can have both functions that were generated for both classes. Once you've been able to reproduce the build, you're now able to call the classes directly from their generated packages. Now, it is important to note that we kept our classes only at runtime. And this is evidenced in our processor. If we go into the annotation, that was retained only at runtime. Now, sometimes our generated code, we might want it to survive a bit longer. And so I will use source compatibility, right? So our annotation will not be stored in the binary output, and it will not be available for reflection. Thereby, if we go back and simply just run our application now, we should see the generated class for name class and email class. So this is code from the generated file. As shown here, right? So it just says this is a generated class. Of course, this is a simple use case, but you can use it to do multiple other things. We can check how the file actually looks like. If we go into our build folder, get into generated, and then look for the source that you want. So in this case, for the name class, and you can see the name class in Kotlin is actually written as a class. So name class generated, and it actually has the function that we provided. That is part one of our in-depth course on Kotlin symbol processing. We have set up our project, created a simple annotation, and wrote a basic processor. In the next video, we'll dive deeper into more complex use cases and advanced features of KSP. Make sure to like, subscribe, hit the bell icon so you don't miss out on part 2. See you in the next video.